about HDMI 2.1 and 8K training with AVProEdge. Matt Murray, who is CTO and founder of AVProEdge and Meridio, he has an almost uncanny ability to understand electronics and has grown to be the core mind behind AVProEdge and Meridio's products. Matt helped develop the Level 3 course for the Image Science Foundation as an ISF certified instructor specializing in Dolby Vision and HDR formats. Please welcome Matt.
Hello, hello. Quite the introduction, but yes, so our companies focus on HDMI connectivity products and test and measurement equipment. So we got asked to come up with some topics for CEDIA, and the topics that we always like to cover are more educational type programs centering around the HDMI technology. This topic can go on for hours and hours and hours, so what we're going to try to do today is distill down a class that we normally give through CEDIA. So if there's anything that you guys want to learn more about, you can approach us or CEDIA, and this is a full-on 2-3 day class that you get CEDIA credits for taking. But basically, the learning objectives of the class as a whole, one is to better understand HDMI 2.1. Two is to have a clear understanding of how to distribute it, because things have changed considerably. So there's a lot of intel and information that goes into this full training course that we won't get into today. So you see the 4 bullets here. What we're going to focus on is kind of part 1, which essentially is just get a little better understanding, because we basically have about 20 minutes. So in 20 minutes, it's really hard to get through a lot. So what I want to focus in on is these buzzwords. So there's several that you guys are hearing out in the field. Consumers are starting to talk about these things. The gaming world is starting to come up. So you're starting to hear this a lot more and more. You're seeing it in marketing on televisions and things like that. So we kind of want to just dig in and see what these actually mean. So we're going to talk today about fixed rate link, FRL, and that's the kind of funny thing with HDMI, right? It's always all of these acronyms: FRL, VRR, eARC, HFR, CDS, ALLM. Everything's got an acronym. Some of them are for very trivial things, and some of them are really important to HDMI and how it works. So we're going to hit on FRL, which stands for fixed rate link, VRR, which stands for variable refresh rate, eARC, which we all know ARC. eARC is probably the most recognized HDMI 2.1 feature that's come out, because it almost seems like day one eARC stuff started coming out, but that's an enhanced audio return channel. HFR is high frame rate. CDS is an incredibly important part of HDMI 2.1 that actually makes eARC work. That's the capabilities data structure. We'll talk about that. ALM, auto low latency mode, and HDR. So we won't talk about HDR today, because while it's probably one of the more important elements, in fact, in my opinion, it's the most important element that's driving all of the new development for HDMI advancing and things like that. We just don't have time, because HDR is a whole class on itself. So the first thing we'll kind of talk about is fixed rate link. So with fixed rate link, what they essentially did was change the specification from an external clock, so where 2 devices had to kind of have external timing. So it's an internal clock on HDMI now, which basically opened up an additional piece of wire, essentially. So we now have 4 lanes, or links is what they call it, and it's an embedded clock. We automatically gained more bandwidth with this, and what it allows us to do is basically come up with a single data rate. So if you guys have dealt with HDMI 2.0 or 1.4, when you change from 4K to 1080p on a TV, what happens? TV goes black. It has to reacquire a new signal. So the whole goal with the fixed rate link is to give you essentially one data rate, and then all of the different video timings can operate under one data rate. So when you change from 1080p to 4K, or some of the later things we'll talk about, high frame rate, variable refresh rate, when you're changing refresh rates and things like that, it can all happen very easily and seamlessly. So this is a major advantage, especially to integrators. And we've been doing this for quite some time, and doing it this way should ease some of the pains and struggles that we've had with HDMI video distribution, particularly because that's kind of when things go bad. When things are trying to reacquire whole new signal types and things like that, that's when things kind of go south. So fixed rate link is a really good thing. We have more data. Right now it's 12 gig per lane that we can get, so 48 gig. There's talks of that being pushed up so we can do some more things under DSC compression and things like that. So just to take a look at some numbers, and this is just a representation of how this is kind of unofficially being talked about right now, especially among other manufacturers and stuff. We're talking about different levels of FRL. So when you're selecting products, or when you're specifying jobs or looking at cables and things, this FRL level, so to speak, is something we should be looking at, because it's basically gonna tell you what types of video signals you can actually get. So the nice thing with HDMI, or HDMI 2.1, it takes away the requirement from the consumer or the integrator to have to try to configure so many elements using EDIT and things like that to make things work. It's just going to discover, okay, I'm capable on this link to do FRL level 2, and then that's what it's going to do. So your infrastructure starts to become more important, obviously, because let's say you have a cable that can only handle X amount of bandwidth. This is going to now limit you on what HDMI video signals can go through. So it's going to start to understand how much actual throughput I have to work with. So very important if you're, and there's a little bit of confusion here, because if if you're FRL 3, you still can do 4K, you still can do 8K. But as you go up, what you're going to start gaining is more deep color, the ability to do less chroma compression. So there's a lot to this. So you can get an 8K signal, but it may not necessarily be 444. It may just be 420 or something of that nature. So so just kind of keep that in mind. And then here's just a representation of the data. So how much bandwidth we're going to get per lane. And I use some people get mad at me for using the word lane, but it's just the easiest way to explain it. But FRL 1 through 6 there, you can see that the data goes all the way up to 48 gig. Currently, our company is working at 40 gigs. So probably next year we'll start seeing 48 gigs, I think, becoming more prevalent. DSC will start coming out, some of the newer video signals. Link training we kind of talked about, but basically that's the embedded clock that basically can figure out what FRL level we're going to be at. So variable refresh rate, this is a really interesting feature that is become incredibly popular already. So gaming is already using this a ton. So this was very quickly adopted in that world. And basically what it does is allows for more dramatic experiences, which is why it came out in gaming first. For instance, you could be running at a 60 frame per second, and then maybe during an action sequence it jumps up to 120 frames per second. So very, very, very artistic feature that allows movie directors, gaming designers, and everything to kind of enhance the whole experience. And the whole idea is to try to make things feel more real. So we're really starting to see that with HDR, which, as I said, is a whole separate topic and a whole separate class. It gives you the visual accuracy. So we went to a contrast-based imaging system. So instead of looking at pure pixels, we're looking at the actual contrast, which is how human vision works. So HDR was a major advancement. VRR starts adding to that element where things can kind of, change speeds and things like that. So great feature. This is out. It's already supported amongst manufacturers today. One thing that's nice with VRR, you can get some of this on HDMI 2.0. So if you have legacy products and legacy cables and things, this is already starting to work naturally. So eARC is another really important function, and this is actually one of my favorite features to come out of HDMI 2.1, because what it did is it essentially gave, it makes the audio return channel essentially like its own link. So if you think an HDMI cable is one way, it's almost like you just have a cable running the audio directly back. So it's not reliant on any other protocols like CEC or anything like that. It's literally just its own connection. So what that does for us, it created a new problem, which we'll talk about, CDS. But what it does is it gives us more bandwidth, number one, so we can do all of the currently available audio types. So that's your Dolby MAT audio, 7.1 channel, DTSX, the whole enchilada. So you get everything on this enhanced audio return channel. It also makes it so that it can have a communication element like with an AVR. So we're going to talk about CDS. Let me get to it here. So I'm going to put this slide up, and this is just kind of an image of how eARC works. I think you guys kind of get it's a back channel of audio, but basically the CDS is what kind of makes this all work. So we picked up this communication. So we talk about EDID a lot in some of our classes, where EDID is a sync device or a display projector, etc., telling a source what it can provide to the sync to make it all work. So this is the exact opposite direction. So now you have an AVR that has an HDMI output. So that output now can tell the input what its audio capabilities are. So if I plug a cable into the TV from an AVR, the AVR now has an understanding of what that TV is certified to send me. So it can optimize itself for said audio signal. So it's not a guessing game anymore. So with ARC and stuff in the past, it was, the default, condition, people would just go and just put it to 2-channel. So, you put it to 2-channel because that's what always works. So now we have the ability for the AVR to be able to see what the capabilities are and respond to it that way. So this is a really powerful feature, and this is what allows like automatic lip sync and things like that to work. And this is, you're going to continue to see eARC grow. So very, very powerful feature with CDS. So this is a representation of an EDID. We could talk for hours and hours about EDIDs, but basically this is just for a real high level understanding of it. It's just data that comes back. So it's the data coming from the TV telling a source what its video capabilities are. And that goes from, what the resolution is, what kind of HDR it supports. It even goes into how much dynamic range it has. So if it's going to be doing Dolby Vision or anything deep color, it knows the source can then do its own tone mapping and things like that. So everything is in the EDID to make all this stuff work. And if you guys are integrators, you know that you've had to deal with this a lot when you're dealing with EDIDs. So next feature we'll talk about real quick is high frame rate. So high frame rate is just exactly what it sounds like. So HFR, we gained an additional 60 frames so that we can have more realistic sports, more realistic gaming, things like that. So HFR, one of the most interesting problems that came up with HFR is as you increase the frame rate, things get more efficient. So video gets basically decoded more quickly. So we're seeing where audio is taking more time to be decoded. So you're having the exact flip of the historical lip sync problem. So you're seeing audio arrive after instead of audio arriving early. So that's a quick tip if you're ever in the field and you're seeing like lip sync where it's opposite of what you would expect, audio is coming later, turn the frame rate down, typically will fix it, because the TVs are, it has to do with the electricity and how it all works and stuff like that. But basically, if you turn the frame rate down, things will start to line up. So that problem's being dealt with. It's one of the things that we're working on heavily within our products to be able to manage that, and essentially try to slow down the video. So, but new challenges are coming up as these things happen. So, ALLM is auto low latency mode. So, basically what auto low latency mode is this is more of a automation to me than anything else. But essentially what it does is, like, if you plug an Xbox into a TV, it automatically turns off all the video processing stuff. So if you're a source device and you want to tell a TV to bypass all processing, you can do that to reduce latency to basically nothing. However, your picture quality will suffer, because one of the things that they bypass is the chroma decoders. So you just kind of have to keep that in mind. If you're going to use this and you want to use game mode and stuff like that, just know that the picture is going to suffer because there's no processing. So I think that's going to continue to get better and better and better as the technology continues to go. But in its current state, that's something you need to look at with game mode. Although the zero latency is really nice if you're a gamer. So the next two slides are basically an illustration of where we were and where we're going to be. So this chart shows HDMI 1.4, which is above the black line in the middle. Below the black line is HDMI 2.0. So there's several more video signals that came with HDMI 2.0. The ones listed on this chart are kind of the most common ones. So those are the ones that we really picked up when we went to HDMI 2.0. And then just to kind of show you where we're going, these are all the new video timings that we're going to pick up as we go to HDMI 2.1. So things are really progressing quickly, and there's a lot more legwork that is going to be needed to kind of get some of these things to work. So you can see that it's a major jump. So we're going from essentially 10 timings to, and this is even a trimmed down one, probably around 100 new timings. But there's some really interesting things if you look even on the full HD. On the very top, 1920 by 1080, 120, 444, deep color. It's an 18 gig signal, but that's an amazing signal. So think about that like sitting at your computer as a gamer. So now you have uncompressed chroma, you've got 12-bit color, and high frame rate at 1080p. So with current infrastructure today, you have this amazing ability to do a high dynamic range video signal at 1080p, which is suitable for most screens, at the right distance, and it's just a incredible achievement that we can do this. So this is all, we can go off into ISF and all of the color theory and stuff, but for generally speaking, you're going to pick up a lot of uncompressed color and a lot of additional deep color with HDMI 2.1. And if you look at the bandwidth data rates, you see the uncompressed side. On the uncompressed side, you can see how much of it we actually get with 9 gig or 18 gig. So just by not doing anything, by using everything we're using today, you get all of this new stuff with HDMI. So it's one thing that I think gets overlooked. We get so caught up in these high numbers and things like that, but HDMI is really doing us a big favor with this. So you can do 8K with current infrastructure right now. So very good stuff. The other side we won't talk about too much today, which is the DSC side. DSC is basically a front-end compression that HDMI is going to use to get to really high bandwidth type signals, like some of these 10K ones you see at the very end. That's not really been, there's some source devices that can do it in the test and measurement world. There's some sync devices that can do it. Some TVs and stuff can already do it, but we don't really have a true consumer video source or anything that can do it outside of really high-end graphics cards and things like that. And there's definitely not repeater type devices, distribution type devices that can support that quite yet. I think it's going to be more like a next year kind of thing. But we'll see DSC grow as this specification evolves. We'll start seeing higher and higher bandwidths. I mean, up into the 500-600 gig per second range that we're going to compress down. So this chart right here, I'm sure people have seen this before. This has been used a lot by HDMI and things like that, but this is just to kind of put things into context a little bit. So HDMI 1.4, that spec came out in 2010. So that was when we first got basically 4K. So 2010 was a long time ago now. HDMI 2.0 came out in 2013. So we're talking almost 20 years at this point, or 10 years, sorry. So we're talking about 10 years, and we're basically just there where all of this stuff is like fully baked. So HDMI 2.0 now I would say is ready. You can successfully deploy it everywhere. There's tons and tons of devices. Every manufacturer here has stuff for HDMI 2.0. It's here, but this is 10 years later. So this HDMI 2.1 spec, and I remember we downloaded it on the very first day it came out. It was November 2017. So in 2017 was when this spec came out and people started working on stuff. So you can see we're just to put timelines into perspective, we're still early in the HDMI 2.1 kind of rollout. So, you know, you're starting to see some distribution gear out there. You're starting to be able to prepare your infrastructure. I can guarantee you fiber is going to become more and more common as we move into HDMI 2.1. But things are starting to get there. The TVs are always first, right? So they're the largest, the most dominant. They're the ones who have all of the R&D and the money, and they start putting HDMI 2.1 and they're there. So the source devices are always slower. So I know that there's major companies working on HDMI 2.1 source devices right now as we speak, but it's going to be quite some time before that stuff is ready. Decoding a signal seems to always be easier than encoding a signal. So just keep that in mind. So by you know, all of these timelines here, I would expect 48 gig HDMI 2.1 to really start feeling a part of the system in 2027. You know, so that's kind of the timelines that I would look at when everything is fully there. And then again, by that time, we're going to have some new spec that's going to require new developments and stuff again. So it's all forward progress stuff. So we talked about EDID. I don't want to hammer into that much anymore. So that's kind of what I had here today, about 25 minutes of this. Again, if you guys want more in-depth HDMI training, this class, we have a whole entire 3-day class. There's a 1-day class and a 3-day class. It's CEDIA. You get RUs for it. We travel around and do it. We can do it in Indianapolis. There's virtual options. Reach out to us or CEDIA. You can get credit again. It's a big topic, and a lot of stuff is changing. We go into how to distribute it, how to troubleshoot it, how to test it, and all those things. So, and that's all I have. Does anybody have any questions?
Any questions?
Thanks, guys. Have a good show.